What if you could freeze cancer and kill it without ever cutting the body open?
A Camden grandmother's life has changed dramatically after doctors destroyed a painful tumour in her spine. The 64-year-old was treated at Liverpool Hospital, the first in the country to harness MRI to freeze tumours in an instant.
No chemo, no radiation, no weeks of recovery. Just ice. Sounds unreal.
But in 2025, doctors in Sydney actually did this in real time, inside an MRI machine. And what they discovered doesn't just change cancer treatment, it raises a much bigger question. What if we could freeze the human body itself and come back later? So first, what is cryoablation? It's exactly what it sounds like. Doctors insert a thin needle called a cryoprobe directly into a tumor and freeze it to around negative 180 degrees Celsius. That forms something called an ice ball inside the body. And that ice literally ruptures cancer cells from the inside, while leaving most healthy tissue around it untouched.
In many cases, patients go home the same day. No major surgery, minimal pain. So naturally, the question is, if this works so well, why aren't we using this everywhere instead of chemotherapy? The answer comes down to one thing. Cancer doesn't stay in one place. What you see on a scan is just the main tumor. But cancer also spreads tiny seeds into the bloodstream, cells too small to detect. Cryoablation can destroy what you can see, but chemotherapy is designed to hunt what you can't.
Think of it like this. Cryoablation is a sniper. Chemotherapy is a smoke grenade. One is precise. The other floods the entire system.
There are also practical limits. It works best on small tumors. It struggles near blood vessels, a heat sink effect. And doctors need clear imaging to even attempt it.
So no, cryoablation isn't replacing chemo anytime soon. But something interesting is happening.
When tumors are frozen and destroyed, they release signals into the body. And in some cases, the immune system starts recognizing cancer elsewhere. Almost like the body just learned what to attack. It's called the abscopal effect. And this is where it gets interesting.
It's almost like the tumor turns into a vaccine against itself. The body finally sees the enemy and knows what to attack. And now researchers are testing cryo plus immunotherapy. Not replacing chemo, but possibly doing something smarter.
And this is where things get interesting, because once you realize we can freeze cells, destroy them, and even teach the body to respond, you start wondering, what if we take this idea further? What if we don't just freeze tumors? What if we freeze the entire body?
We already do something similar today.
We freeze embryos. We store stem cells. We figured out how to pause life on a very small scale. But a whole human? That's where things start to fall apart. Now this sounds extreme, but people are already doing it. There's an organization called Alcor, and their goal is simple: preserve your body after death and wait for the future to catch up. But freezing a human body isn't that simple because of one problem: ice. Human cells are mostly water, and when water freezes, it expands, about 9%. That might not sound like much, but inside your body, that creates millions of microscopic ice crystals. And those crystals act like tiny knives. They tear through cell membranes, destroy structures.
Think of a soda can left in the freezer.
It doesn't just get cold, it bursts. Now imagine that same expansion happening inside every single cell in your body. And the result is something closer to a slush.
So instead of freezing, they use something called vitrification.
Blood is replaced with cryoprotectants, basically medical-grade antifreeze.
When cooled rapidly, the body doesn't form ice. It turns into a glass-like state. No crystals, no tearing.
But there's a problem. Those chemicals are toxic. Which means, right now, there's no safe way to bring someone back.
So why do people still do it? Because they don't see death the same way. To them, death isn't the end. It's a problem we haven't solved yet. Think about it. If you had a heart attack 100 years ago, that was it. Today, an ambulance can bring you back. Cryonics is the same idea, just stretched across time. It's an ambulance to the future.
So the real question isn't whether this works today. It doesn't. The question is, would you take the chance? Would you accept 100% gone? Or bet everything on a 0.0001% future? Let me know what you think. And if you're interested in where biology, technology, and AI are heading, subscribe.
Because next, we're looking at something even bigger. Not Plan B, but Plan A. Don't die.